Elements of group 16 oxygen family. Elements to group 16. Elements to group 16. Group 16 elements to group 16 oxygen family. Oxygen family. Okay. Elements of group 16. Elements of group 16. Elements of group 16 oxygen family. Okay. Oxygen family. Elements of group 16 oxygen family. Okay. Oxygen, sulphur, selenium, tellurium, and polonium are placed in group 16. Are placed in group 16. In group 16. Okay. Oxygen, sulphur, selenium, tellurium, and polonium. Oxygen, sulphur, selenium, tellurium, and polonium are placed in group 16 of the periodic table. Group 16 of the periodic table. Okay. All the elements are normal elements and p-black elements because their outermost electronic configuration is ns2 and p4. Okay. All these elements are normal elements and p-black elements. All these elements are normal elements. And p-black elements. Okay. P-black elements because their outermost electronic configuration is because their outermost electronic configuration is ns2 np4. On the basis of the name of first element, these are also called the elements of oxygen family. The 5 elements oxygen, sulphur, selenium, tellurium, and polonium. Okay. Polonium are collectively called charcogens or ore forming elements. Okay. All elements of oxygen family, all elements of oxygen family are collectively called chalcogens. Chalcogens are ore forming. Okay. Elements. This is because many of the metallic ores are found in the form of oxides and sulfides. Okay. Priestley discovered oxygen by heating red oxide of mercury in 1774. Okay. Priestley discovered oxygen by heating discovered oxygen by heating red oxide of mercury in 1774. Okay, the name of oxygen was given by Lavoisier. The name of oxygen the name of oxygen is the name of oxygen was given by Lavoisier. Okay, oxygen is the most widely distributed and most abundant of all the essential to life process, supporting respiration and combustion. In Earth crust, oxygen occurs as a constituent of all the silicates. Oxygen occurs 89% by weight in seawater. Okay, oxygen occurs 89%. Oxygen occurs 89% in the earth. Oxygen occurs 89% by weight in seawater. Okay, by weight in seawater. Okay, and sulphur is widely distributed in nature, both in the free and in the combined states. In the combined states, sulphur occurs as a sulfide ores. Okay, sulphur is present in coal in small quantity. The other elements of the family are found in much lesser quantities in earth crust. Selenium, tellurium, and polonium are found respectively in 10 to the power 7, 10 to the power minus 7, and 10 to the power minus 14%. Polonium is radioactive. Okay, polonium is radioactive. Polonium is radioactive. Okay, electronic configuration. Next, electronic configuration. Okay, electronic configuration. Element, symbol, atomic number. Electronic configuration. Okay, element, symbol, atomic number, and electronic configuration. Element is oxygen, symbol O, and atomic number 8. Okay, and after oxygen, the next element is sulphur. Next element is sulphur. Okay, symbol is S, and atomic number is 16. Next element is selenium. And symbol is Si, and atomic number 34. Next element is tellurium. Okay, after selenium, the next element is tellurium. okay, Te, and the symbol is 50, atomic number is 52, and other next element is polonium. Other next element is polonium, and symbol is Po. Electronic atomic number is 84. Okay, and all the electronic configuration of all the elements is 1, 2, 6, or 1s2, 2s2, 2p6. Okay, 2p2. Okay, 2 to 4, 2p4. 2p4, 4 to 6 to 8. Okay, and electronic configuration of sulphur is, the electronic configuration of sulphur is 2, 8, 6. 2, 8, 6, or 1s2, 2s2, 2p6, and 3s2, 3p4. Okay, 3p4. Okay, and 1s2, 2s2, 2p6, 3s2, 3p4. And the electronic configuration of selenium. Electronic configuration of selenium. 2, 8, 18, 18, 8, 26 to 28, 28, 34 minus 28, 6. Then 6. Okay. 1s2, 2s2, 2p6, 2p6, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p4, 4 to 6, 10, 4 to 6, 10, 16, 6, 22 to 24, 6, 30, 32, 34. Okay? And the electronic configuration of tellurium. Electronic configuration of tellurium. Okay? 2, 2, 8, 18, 18, 6. Okay? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 3d10, 4s2, 4p6, 4d10, 4d10, 5s2, 5s2, 5p4, 5s2, 5p4. Okay, 5p4. Next element is polonium. Next element is polonium. Okay, next element is polonium. The electronic configuration of polonium is, the atomic number of polonium is 84. Electronic configuration of polonium is 2, 8, 18, 32, 18, 6, or 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4s2, 4p6, 4d10, 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 4f14, 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 5s2, 5s2, 5p6, and 5d10, and 6s2, and 6p4. 6p4. This is the electronic configuration of all the elements of oxygen family. Okay, this is the electronic configuration of all the elements of oxygen family. Okay, occurrence. Outermost general electronic configuration. Outermost general electronic configuration is outermost general electronic configuration is NS2NP4. All the elements are p block elements. All the elements are p block elements. P block elements. All the elements are p block elements. All the elements are p block elements. All the elements are p block elements. Okay. P block elements. Oxygen and sulfur are non-metals. Oxygen and sulfur. Oxygen and sulfur are non-metals. Non-metals. Oxygen and sulfur are non-metals, and selenium, tellurium are semi-metals. Okay, and selenium and tellurium is semi-metals. Semi-metals. Otherwise, polonium is metals. Polonium is metals. Okay, polonium is metals. Okay, next heading occurrence. Next heading occurrence. Okay, occurrence. Next heading occurrence. 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 Oxygen occurs free in the atmosphere and in the combined state in water, H2O, oxide, silicate, sulfur, phosphate, rocks, and minerals. Okay? Oxygen occurs free in the atmosphere. Oxygen occurs free. Oxygen occurs free in the atmosphere. Oxygen occurs free in the atmosphere and in the combined state. And in the combined state in water. Combined state in water, H2O, and oxide, silicate, sulfur, phosphate, rocks, and minerals. Okay. Oxygen occurs free in the atmosphere. Oxygen occurs free in the atmosphere and in the combined state in water, H2O, and oxide, silicate, sulfur, phosphate, rocks, and minerals. Okay. B point. Sulfur also occurs in free state and in combined state of sulfide. Sulfur also occurs in free state. And in combined state as sulfide. Combined state as sulfide. FeS2 ZnS PbS HGS. Okay, etc. etc. C point. Selenium and tellurium occurs in trace amount in sulfide ores. Selenium and tellurium occurs in trace amount amounts in sulfide ores. Okay, selenium and tellurium occurs in trace amount in sulfide ores. D point. Polonium is radioactive. Polonium is radioactive. Polonium is radioactive decay. Radioactive decay product of radioactive product of radioactive elements. Okay, radioactive elements. And next heading diagonal relationship in oxygen and chlorine. Diagonal relationship in oxygen and chlorine. Okay, diagonal relationship in oxygen and chlorine. Oxygen and chlorine. Okay, diagonal relationship in oxygen and chlorine. Oxygen shows diagonal relationship with chlorine of group 17. It differs in many of its properties from the other elements of group 16. It shows similarity with chlorine in many of its properties. Okay, similarity of oxygen with chlorine. Similarity of oxygen with chlorine. Okay, similarities of oxygen with chlorine. First point. Both are gaseous elements. Both are gaseous elements. Both are gaseous elements. Okay, second point. Both are metals. Both are non-metals. Both are non-metals. Both are diatomic. Both are diatomic. Both are diatomic. Okay. Fourth point. Both are strong oxidizing agent. Both are strong oxidizing. Both are strong oxidizing agents and very much reactive elements. And very much reactive elements. Both are highly electronegative elements. Both are highly electronegative elements. Both are highly electronegative elements. And sixth point. both form stable hydrides like both form stable both form stable hydrides both form stable hydrides like H2O and HCl, okay? And dissimilarities of oxygen and chlorine. Dissimilarities, dissimilarities, similarities, dissimilarities of oxygen and chlorine. 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 Okay. Dissimilarities of oxygen and chlorine. Dissimilarities of oxygen and chlorine. Okay. Dissimilarities of oxygen and chlorine. Although oxygen and chlorine show diagonal relationship, but they also differ in some aspects. Although oxygen and chlorine show diagonal relationship, but they also differ in some aspects. First, oxygen is bivalent. Oxygen is bivalent. Oxygen is bivalent, whereas chlorine is monovalent. Chlorine is monovalent. Second point. Chlorine is more reactive in comparison to oxygen. Chlorine is more reactive. Chlorine is more reactive in comparison to oxygen. In comparison to oxygen. Okay. Third point, oxygen does not react with sodium hydroxide. Oxygen does not react. Oxygen does not react with sodium hydroxide. Oxygen does not react with sodium hydroxide, but chlorine react as follow. Chlorine reacts as follows. A. Dilute and cold sodium hydroxide. Cl2 plus 2NaOH. 2 sodium hydroxide. 2 molecules of chlorine and 2 molecules of sodium hydroxide react with and make that NaCl, sodium chloride, plus NaClO plus H2O, where dilute and cold sodium hydroxide. Dilute and cold sodium hydroxide. Okay. B point. And hot sodium hydroxide. Okay. 3Cl2 plus 6NaOH. That makes 5NaCl sodium chloride plus NaClO3 plus 3H2O. Next heading, anomalous behavior of oxygen. Okay, anomalous behavior of oxygen. Anomalous behavior of oxygen. Okay. Anomalous behavior of oxygen. Anomalous behavior of oxygen. Okay. First member oxygen of the group differs in property from the rest of the members. The causes of anomalous behavior of oxygen are the causes the causes the causes of anomalous the causes of anomalous behavior of oxygen are: first, due to small size of oxygen. Due to small size of oxygen. Second point, high electronegativity. High electronegativity. Third point, absence of d orbital in the configuration. Absence of d orbital in the configuration. Absence of d orbital in the configuration. High ionization energy. High ionization energy. पांचवा point. Fifth point, ability to form H bond. Ability to form hydrogen bond. Sixth point, less catenation property. Less catenation property. Okay. Difference between oxygen and the rest of the members. Difference between oxygen and the rest of the members. Okay. Difference between oxygen and the rest of the members. Okay. Due to the above, oxygen differs in property from rest of the members in following aspects. First point, oxygen is gas but other exist as X8 solid. Oxygen is gas but others exists as X8 solid. Okay. Second point, oxygen is most electronegative element. Oxygen is most electronegative. Oxygen is most electronegative element of this group. Okay. Oxygen is most electronegative element of this group. Hence, compound of oxygen are more ionic in nature. Hence, compound of oxygen are more ionic in nature. ionic, more ionic in nature, more ionic in nature. Okay. Third point. Oxygen forms hydrogen bond. Oxygen forms hydrogen bond. Hydrogen bond. Oxygen forms hydrogen bond. Hence there is hydrogen bond in H2O. Hence there is hydrogen bond. There is hydrogen bond in water. But not in H2S, H2SI, H2SI, H2TE, etc. Other members of the group do not form hydrogen bond. Other members of the group other members of the group do not form hydrogen bond. That is why the property of oxygen compounds differs from the properties of the other members compounds. Okay, due to hydrogen bond, water boils at high temperature than H2S. Due to hydrogen bond, H2O, H2O boils at high temperature, than H2S. Fourth point. Maximum covalency of oxygen is 2. Maximum covalency of oxygen is 2, and others have 6. Okay, this is due to non-availability of d orbital in oxygen, while others have. This is due to non-availability This is due to non-availability of d orbital in oxygen, while others have. Fifth point. Oxygen is paramagnetic. Oxygen is paramagnetic, while sulphur 8, selenium 8, and tellurium 8 are diamagnetic. The paramagnetic behavior of oxygen is due to presence of 2 unpaired electrons in oxygen molecules. Okay, the paramagnetic behavior of oxygen is due to presence of 2 unpaired electrons in oxygen molecules. Okay, 6th point. Oxygen is highly stable than others. Oxygen is highly stable than others. than others. Okay. Thus, oxygen reacts with other elements at a high temperature. That is why oxides ore are lesser in number than sulfides ores. Okay. 8 point. Oxygen has a little catenation property, but others form long chains. Okay. Oxygen has little catenation property. Oxygen has little catenation. Oxygen has little catenation property. Little catenation property. Okay. Oxygen has little catenation property, but others others form long chains. Form long chains. Long chains. Okay. Sulfur has pronounced catenation property as in H2SnO6 n equal to 2 to 6. Okay. Oxygen does not show plus 4 plus 6 oxidation states. Oxygen does not show plus 4 plus 6 oxidation state. Oxidation state, but others show. Okay. Others show. Next point. Point 9. Hydrides of oxygen is liquid, while other hydrides exist in gaseous form. Okay. Hydrides of oxygen is that H2O is liquid, while other hydrides H2S, H2SA, etc. exist in gaseous form. H2S, H2SA, etc. exist in gaseous form. Exist in gaseous form. Okay. Comparison of oxygen and sulfur. Next heading. Comparison of oxygen and sulfur. Comparison of oxygen and sulfur. Oxygen and sulfur, the first two elements of group 16, resembled each other in many respects. The resemblance is due to the fact that both contains the same outermost electronic configuration ns2 np4, and both contain 6 electrons in the outermost orbit. Okay. Outermost orbit. Okay. Property oxygen sulfur. Okay. Property points of similarity. points of similarity. Points of similarity. Okay. Comparison of oxygen and sulfur. Okay. Points of similarity. Okay. Then first point. Nature. Second point. Electronic configuration. Third point, oxide. Fourth point, allotropy. Fifth point, extraction. Sixth point, presence. 7th point, reaction with hydrogen. Okay. Oxygen, non-metal. Nature, non-metals. Okay. And sulfur is non-metals. Okay. Second point, electronic configuration. NH2NP4 oxide. 2S oxide. The NH2NP4, that means 2S2 and 3S2 3P4. Okay. Oxide, O2R, O2, O3, oxide, O3 are oxygen, O2, that is oxide, SO2, and allotropy shows. Okay. And extraction by decomposition of higher oxide. By decomposition of higher oxide, by decomposition of higher oxide. By decomposition of higher oxide. By decomposition of higher oxide. Presence, free state. Okay. Reaction with hydrogen, H2O is formed. And H2S is formed. And H2S is formed. Okay. Points of dissimilarities. Points of dissimilarities. Points of dissimilarity. Okay. First point, state. atomicity, 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 3 point, occurrence, occurrence, 4th point, valency, 5th point, dihydride, okay, dihydride, 6th point, 6th point, 6th point, oxidation state, oxidation state, 7th point, combustion, combustion, 7th point, combustion, 8th point, 8th point, hydrogen bond, and 9th point, reaction with nitric acid, reaction with nitric acid, HNO3, okay. Then first is state of oxygen, gaseous state, okay, and sulphur is solid state, okay. Atomicity, diatomic, O2, and sulphur, polyatomic, S8, polyatomic, S8, or monoatomic, S, okay. Occurrence, waste, great extent, occurrence, vast, great extent, okay, great extent, okay, less extent, sulphur, less extent, okay, and valency, +2 maximum, valency +2 maximum, +6 maximum, dihydride, colorless neutral liquid H2O, colorless neutral liquid H2O, okay. Dihydride, colorless neutral liquid H2O, and rotten egg smell, acidic, rotten solid, dihydride of sulphur is rotten egg smell, acidic, H2S, gas, and oxidation state -2, -1, +2, and oxidation state of sulfur is -2, +2, +4, +6. Combustion, helpful in combustion, helpful in combustion, helpful in combustion, and oxidizes itself, oxidizes itself, okay, oxidizes itself, okay. And hydrogen bond, oxygen form hydrogen bond, oxygen form hydrogen bond, otherwise sulfur does not form, sulfur does not form. Reaction with nitric acid, oxygen does not react, otherwise sulfur is oxidized, sulfur is oxidized, sulfur is oxidized, sulfur plus 6HNO3 nitric acid that make H2SO4 plus 6NO2 plus 2H2O, okay, plus 2H2O. Next reading. Comparison between sulfur and selenium. Comparison between sulfur and selenium. 1 minute. Comparison between sulfur and selenium. Okay.